Good. So good afternoon again. Welcome to this afternoon session. We're doing CXC Physics Revision, and we'll be looking at the January 2020 paper one. All right, so let us begin by looking at the first question on that paper. So we'll work question one first. Very simple question. So you can type in your answers for question one and question two. All right, so several persons already start sending in their answer for question one, which is indeed D. The instrument used to measure the diameter of a human hair is indeed a micrometer screw gauge. Question two. Express this number here in standard form, and this is a very popular question in the exam. So we just move our decimal point 1, 2, 3, 4, 5 places. So it is 4.62 times 10 to the minus 5, which is A. All right, so these two are simple. I see everybody, or most persons who send in the answers getting that correct. Question three. So let's look at question three first. The question asks you, what is the volume of the liquid shown? Remember that when we are taking a reading, we must read at the bottom of the meniscus, right? So it is not going to be 8. That is completely wrong. So we have to take the bottom of the meniscus. So that is going to be 7.5, which is B. Good, and I'm glad that everybody is agreeing as we go along here. So question 5, the thermometer is not shown. So probably I'll have to look back and see if another picture it is showing. All right, so question 5, you cannot answer. I think I have to put a picture of the thermometer. I see some person sending in an answer they do. But the thermometer is not shown, so you can't take the reading. Sorry about that. Question 6. When standing on the moon, the mass of an astronaut is 70 kg. When he returns to Earth, his approximate weight is going to equal to, so we're using the formula W is equal to mg. So that will be 70 times 10, which is 700 meters. All right, so I'm seeing a lot of D's there. So yes, everybody's sending D. You're correct, yeah. Question 4. So you can take a read while I'll talk. So you'll probably see that we're not working in order of the paper simply because the structure of the paper, how it is, all of you know how the paper looks. So it's basically when I was editing the picture of the paper to get onto the screen, this is how I get the questions. All right, so question 4, it simply asks you, in the experiment of to locate center of gravity, why do we use a plumb line method basically? And it is, yes, I'm seeing the answers coming through there. It is C, to show which points are vertically below the pivot. So question 6 we worked already. So question 7 now. So at question 7, it asks you which of the following is a derived unit. And yes, indeed, okay, I'm seeing some person saying A, but it is C. All right, Kelvin rather, seconds and the kilogram, they're all fundamental quantities or fundamental units rather. A derived unit will be when we use more than one fundamental units, and we'll end up with a derived unit. All right, so we go to question 8. And the reason why I'm pausing, because a lot of students did not see this paper before. This is the first time they're seeing it, so I'm giving them a chance to read through the question so they get answer it correctly. All right, so 3 persons already start selecting their answers for question 8. So yes, indeed it is A. When the person returns, when the person is sticking to the moon, rather, the mass is going to remain the same. However, the weight is going to be less than what it was on Earth. Question 9. So by working past papers, most of you will have seen these questions. This question 9 is a popular question. It is what we call a repeat question. And indeed, yes, I'm seeing everyone saying it is B. So questions that I'm seeing everybody's getting correct, I'm not going to go through the explanation. We just go through that faster because as we meet more challenging questions, we will spend time on those questions. So question 9 indeed is B. Question 10. Tells us here that a glass marble X, it is moving in a speed with a speed of 6 meters per second, collides head-on with an identical stationary glass marble Y. What is the speed of Y after collision, assuming that X is brought to rest? And again, this is a repeat question, and this is going to be C. Question 11 is also a repeat question from several papers, so most of you probably already know the answer. So low center of gravity, indeed, it is an answer. So what was one other possible answer? Which of the following features must be present in a stable, well-designed racing car? So low center of gravity is one. What is the other one? There are two things that we normally use. The other option is not here, but so what would have been another possible correct answer? Yes, so I'm seeing someone type in the answer there. It is wide base area. All right, so when you're revising, you will know that the two main features of a stable, well-designed racing car are wide base area and low center of gravity. Question 14. All right, so I'm seeing some person saying A, some saying B. So let me give a chance for more answers to come in. So what we need to do here is to look at how the units are canceling out. All right, and then we can make a proper decision. Once in a while, when you see my screen is changing and we're still on discussing something, it simply means that someone has just entered the classroom. And whenever I choose to admit that student, my cursor will change and causing rather the slide to change. So let's look at the units. Here we're going to see that we have cm cube, that's A, I'm looking at option A. We have meters and we have millimeters. So definitely this one is out because those units cannot cancel themselves. For B, you see we have meter cube, we have meter, so yes, that can cancel. We have kg and we have per kg, so it can cancel. So B is a possible answer. We're not going to go with that that is the answers yet. Let's look at the others. We see we have per cm cube here, and we have meters, so more likely. And this way we have grams, and we have per kilogram. So this is not an answer, correct answer, right? So then here we have per meter cube, cm. So this is not the answer. So definitely the answer is B. So if a similar question comes probably for another topic, this is one way of you examining the question quickly. Just look and see how the units are canceling. Good. So we take a pause in the questions here, and I just want to tell you that I'll be hosting two other marathons for physics marathon, meaning we're working out a whole paper on the 29th and the 30th of July. Those will be the 2 days just before the physics exam. So if you're interested, and probably there are some other schools or students rather joining us today. If you're interested in joining, you can probably just WhatsApp me on 6258445. You can send me a message and I will send you the link later on. All right, so just that on the physics marathon. At the same time, I just want to tell you that I'll be hosting a chemistry marathon, well, actually two of them, on the 4th of August and on the 2nd of August. And again, if you're interested, you can send me a message to join those subject marathons, right, where we'll be working out an entire paper for that day. So we move on to question 12. How many schools do we have here? Just type out the name of your school. Let me see how many schools we have here today. Okay, so we have JC. Let me just probably write it down there. So I have JC, Line Path, Bushlot Secondary, that's on the West Coast. Bushlot Mackenzie High. Tagore. So I think that's it. Let me just go back through. Oh, yeah, sorry about that, Devendra. Yes, we have multi. Yes, Devendra, I see you type it back there again. So we have New Amsterdam multi. Yes, you're the only multi student. That's why you got lost in all of the schools here. Yes, we have 2, 4, 6 schools with us. One from region 10, one from region 5, and the rest region 4 and 6. All right, so we go back to question 12. So it tells us here, when two bodies collide, momentum is conserved. What does this mean? And this is a repeat question. So persons who have been working past papers, right away you're supposed to know which answer we're looking at. Indeed, it is D. All right, so we go to question 13. Question 13 is asking us, what is the formula for speed? And I hope you note here, it is speed and not velocity. Good. So we have sorry about that. So we have several persons, and indeed you're correct in saying it is distance travel over time taken. So let's go through the other options. Change in velocity by time taken. Which quantity is this here? Again, it's just a bit of revision. Okay, good. Yeah. So this is acceleration. Change in displacement over time taken. And I know some persons your messages are coming a bit later because again of the internet connection. All right, so rightfully, yes, this is velocity. We note here this is nothing, right? This is basically this formula just rearrange to make it a distractor. All right, so we worked question 14 already. It's just that I repeat this slide. Sorry about that. Okay. Question 15. It asks us here, which of the following sources of energy are classified as renewable? Renewable means that it is always going to be there. It's not going to finish, right? So the answer there is indeed D. I see most of you saying D. Some of you are not too sure about the geothermal, but the geothermal we getting that from the earth, right? So it is actually 1, 2, and 3. Question 16. So question 16 deals with heat capacity of a substance, and it is said it is defined as the amount of heat energy something. Okay, so it is the amount of heat energy needed to raise the temperature of a substance by 1 degree Celsius, or we can say also 1 Kelvin. Um, the heat energy required to change the substance to another state, this is actually called latent energy, right? So in case when you're revising, you'll know that that's not heat capacity, but that's latent heat energy. And for the same question 16, if we wanted to talk about specific heat capacity, then we'll have to say about not only the temperature of a substance, but 1 kg of that substance. So if we said 1 kg of the substance, then this would have been specific heat capacity. So again, all those are just a bit of revision pointers as you're working it. Question 18. So it tells us this is a cooling curve basically. And it tells us that at Q, the substance starts to become solid. So during which phase of the stages rather, is the substance a liquid? Or so remember again that this substance is starting to become a solid at this point here. And this is a coolant, so it is cooling from something, and then it start goes to become a solid. So I'm seeing different answers. I'm giving you a chance to think back about your answer. All right, so the persons who are saying it is actually between P and Q. So this here is going to be the liquid stage. P and Q is going to be liquid. From here now, it is going to be solid and liquid. So this is liquid. Here it is going to be solid plus liquid. And here now it is only going to be solid. All right, and for my students, we will have done this experiment. I am not certain if the other schools will have completed this experiment, but it was one that we had to find the melting point of margarine. Some schools probably use candle also, the melting point of candle. Or I see somebody say they did a melting point of sugar. All right, so we go to question 17. So question 17 deals with conservation of energy. And it asks you here that if you throw a ball vertically upwards and it reaches the maximum height it has in terms of potential and kinetic energy. So as we, let's say this is a ground and this is the top of the, that you're throwing this ball upwards. As it moves more towards the top, we expect that the potential energy is also going to increase. Now, if potential energy is increasing, then it means that our kinetic energy is decreasing. All right, because both of them at the end, it is going to add up to be 100%. So that is going to be which response we're looking at here. Maximum potential, minimum kinetic. So that is C. Question 19 is a very simple one. And just a reminder again, for those who are not participating, remember to type in your answer as we move from question to question. It is okay if you are wrong, but at least you are participating. You're sharing your answer with me. And I can probably see if you're way off, I can tell you, you know what, this is why you're wrong, and something like that. All right, so question 19, yes, this is a giveaway. Since primary school and grade 9 exam, you had to know this. Why do we use wood or plastic? Is simply because to avoid this process of conduction. Question 20. It says here to check the upper fixed point on a thermometer on the Celsius scale. What do we do with the thermometer? We place it in melted ice at atmospheric pressure, boiling water at atmospheric pressure, water in contact with melting ice at atmospheric, or steam above boiling point at 100 at atmospheric pressure. All right, so I'm seeing a few asterisks on the answers, meaning that some persons are not too sure what is the answer, but it is D. All right, boiling water, for those who are thinking probably it is D. Because of impurity, water may or may not boil at 100 degrees Celsius because it is pure water that boils at 100 degrees Celsius. However, the steam that comes out of boiling water is going to be at 100 degrees Celsius. So that is why it is preferred that in this experiment, and if you can check your textbooks back, you will see that to find the upper fixed point, we place it in steam above the boiling water. So we'll have a container. Let me say that's a beaker. We have water inside. Water is boiling, and the steam that is coming out here, then that's where we place our thermometer. All right, so that will be the answer. D. 21. In the pressure law, which of the following statements is true? So we should know that in Boyle's law, the temperature is constant. In Charles' law, it is the pressure that is constant. And in pressure law, the volume is constant. These are the constants. So we're looking at B, volume is constant. Good, so we move on to question 23. Now, this is a formula you can just memorize. It is in your textbook, or you can just understand the concept. So let me just work it while as persons are sending in answers. We know that specific heat capacity is basically equal to EH over M delta T. Well, this question is using delta theta, so I'm going to use theta. Now, EH is also equal to power times time over M delta theta. And power is equal to IV. So that will be equal to IV T over M delta theta. So the option there is, the answer rather is going to be C. All right, so we have under 10 minutes remaining for this session of the Zoom class. Whenever the time runs out, you just log in back using the same username and password, and we will continue. All right, you're not logging out now. You wait until the class finishes, this session rather finishes, and then you log in back. I'm just telling you in case the time runs out and I don't realize it. So on screen right now, you're seeing questions 22 and 24. So let's look at 22 first. So you can type in your answers at 22. All right, so I'm having two couple answers. I'm having Joule and I'm having Rumford. So let's talk about which one is correct here. Now, Rumford did a cannon-born experiment. All right, and his experiment was basically based on or disproving the caloric theory. All right, but for the concept that this question is relating to, it is Joule. So the answer there is A, Joule. But Rumford was talking about the cannon-born experiment where bits of the metal were falling off, and he's seeing that, you know what, the temperature is not decreasing. All right, so we go to 24. Which of the following is not an example of evaporation? So 24. Which one is not an example of evaporation? All right, so once in a while I may miss some of their messages. I just read a message from a student, but just want to know in case I don't respond to your concern is simply because there are lots of you in the class. I didn't check and see how many persons right now. 21 participants, including me. So and a lot of persons are messaging. Well, a lot of you are responding, which is good. So I have to read very quickly the chat. All right, so yes, so everyone is saying it is D, and that is correct. I see someone saying C though, but the answer is not C here because if we leave a container, let's say we leave a Petri dish, and we have some, this is a common experiment, so I'm going to talk about that first. If we leave some water inside, it is because of evaporation that the water level is going to decrease because water is going to start evaporate at the top of the top layer, and then eventually more and more of the water is going to evaporate. All right, so it is the same concept here. So we move on to question 25. 25, yes. This is a standard experiment that is being done, and this is a repeat question. So what is this experiment basically showing? When we place them, let me just tell you, in case I didn't do this experiment, I can't recall if I did this experiment with this current batch of students. But when we add heat here, eventually what we're going to see is that there are bubbles present here, which is telling us that this water is boiling, meaning that so this here is approximately 100 degrees Celsius. And at the same time, we're not seeing the ice melting rapidly. What that is proving is that the water is a poor conductor of heat energy because the heat energy is not being transferred quickly from this point to this point here. All right, so the answer there is that water is a poor conductor of heat energy. So that is C. And this is a repeat question. It appears a lot in papers. So we go to 26. It tells us here that the heat energy required to change the state of a substance was determined to be EH. If the mass of the substance was double, what will happen to the value of EH? So we know that the formula is EH. Again, I'm seeing lots of correct answers here. I'm just going to talk about it quickly while it's ML. So basically saying that if we double this value, if we double this one here, so that's 2 ml, we expect that the EH value is also going to be double. All right, so the answer there is going to be double, which is E. Good, so we go to 27. So 27 is showing a longitudinal wave train on a slinky. And it asks us here which diagram, which option rather, represents the wavelength of the vibration. So let's look at each option. So the first one is A to B. So that is from here to here. This is not a one wavelength, it's actually half of a wavelength. Because we have to look from, it is actually between two compressions or two rarefactions. So it is not A. We look at B, which is A to E. And A to E is actually one, two, sorry, this is one and this is two. Two wavelengths, so that is not correct there. C to E, yes, C to E here is indeed one wavelength. We start with a compression and we end with a compression here. So the answer there is indeed C. The next part there, which of the following electromagnetic waves has the shortest wavelength? So for those who don't normally memorize these things, you can just remember it at all. Shorter the wavelength, it means greater the frequency. So the question is asking which one there has the greatest frequency. And greatest frequency mean which one is the most dangerous. So out of these four here, it is gamma rays that is most dangerous. My students, I will have shared a mnemonic recently. I can't recall a mnemonic. I got it from somewhere. How to remember the order of the electromagnetic spectrum in terms of wavelength. So, I mean, probably some of you are applying that mnemonic. All right, somebody's typing it. I Okay, so it is, remember I visited your ex-girlfriend. Remember I visited your ex-girlfriend. All right, so that is just a quick way of noting that. All right, so we have less than a minute. This session is going to end in a couple of seconds. So when it ends, just log in back with the same username and password, and we're going to continue. Right, remember to keep trying. Don't be discouraged that you're not getting through. Right, just try back to log in.